chemical reaction, so please fill this in as you go. Starting out with this question of the day, this is just a practice balancing equation, so go ahead and write this on your notes page. Remember to write out all the elements on each side of the arrow and write how many of each one you have. So for example, on the left you have 1 iron. As a shortcut, the ClO3, since it appears on both sides of the arrow, you can keep it as 1. So like on the left side, ClO3, you have 3 of those. On the right side, your ClO3, you only have 1. So go ahead and balance that. Okay, so when you balance that, you should have a 2 in front of the Fe, and then a 3, and then a 1, and then a 6. Again, today we're going to talk about writing chemical equations and just practice that a little bit more. So please just remember the 3 steps. The first one is to translate the starting chemicals into formulas. And then we predict the products and write their formulas. And the last step is to balance the equation by changing the coefficients. So let's go ahead and practice that. We're looking at the reaction aluminum carbonate with heat produces what? So step 1, we need to translate those starting chemicals into formulas. So it says aluminum carbonate. So first I would go to my list of polyatomic ions and find carbonate, which is CO3 -2. Aluminum had a +3 charge, so I just swapped and dropped those charges. Because it's an ionic compound, it would be solid at room temperature. So there's one of my starting compounds. Predict the products of the reaction and write its formula. Knowing the type of reaction is going to help you predict your products a lot. So if heat's added, if it says with heat, it's usually a decomposition reaction. When we start with only one reactant, like in this case, we have aluminum carbonate, there's only one reactant. That's another clue that it's a decomposition. So if I'm starting with one thing and then it reacts and breaks into smaller pieces, that's going to be a decomposition reaction. I have attached the spark notes, which are basically just helpful notes. Those are in your slides. You can go and look at those anytime you need to. Okay, so we're starting with this metal, Al2CO3. The spark notes guides tell us that it is type A decomposition. Again, Al had a charge of 3, O had a charge of -2, so I swapped and dropped those charges to figure out my formula. Okay. Carbon dioxide is CO2, and it's a gas. So the reaction is Al2CO3, which is a solid because it's ionic. Then we have Al2O3, that's one of my products. My other product would be CO2, which should say gas, not solid, after CO2. That was an accident. Okay. Notice that this little triangle above the arrow is written. Anytime you see that, that just means that heat's being used to start a reaction. Step 3, we need to balance the chemical reaction by changing the coefficients. So again, this is where you would write out each element on each side of the arrow. So like on the left, I have 2 aluminum, and then I have 3 CO3s. On the right, I have 2 aluminums. I have 3 oxygens. So in this case, CO3 is not written on both sides of the arrow, so I need to write out how many carbon I have and how many oxygen I have and go from there. So this is already balanced for you. All you had to do was move the 3, add that 3 in front of CO2. So now I have 3 carbons on both sides of that arrow, but I also have 6 oxygens on both sides, so everything is balanced. Okay, let's try another one. A strip of magnesium is placed into a solution of copper 2 chloride. Predict the products. So this is what copper 2 chloride looks like as a solution. It's this light blue colored liquid. It is toxic. There is a demo of this reaction on the class website, so please go watch that right after this notes video. So translate the starting chemicals into formulas. I have magnesium, which is a solid at room temperature, and I have CuCl2. Because it's a solution, that means it's dissolved in water, so it would be aqueous. So Mg plus CuCl2. Predict the product. So first, it's helpful to know what kind of reaction this is to help predict your product. If I have one element and a compound on the left side, I already know that it's going to be a single replacement reaction, and the metals are basically going to switch places. So our product would be MgCl2 plus copper. So what's happening in this reaction is magnesium and copper are basically switching places. Magnesium wasn't bonded to anything, and now it's bonded to the chlorine. We still need to balance, which we will do here in just a second. So I have magnesium metal. I added that to copper 2 chloride, and there was a reaction that happened. It should look like this. Again, please go watch the demo video when you're done with this video. So how we know that there's a reaction that's going to happen is by this activity series chart. You should have learned this briefly last year. So reactivity decreases as you go down. That means the metals higher up on the list are more reactive. So I'll talk about what that means. Metals higher up on the activity series will replace metals that are lower than them in a solution. So magnesium is a lot higher than copper. Here's magnesium, here's copper. So magnesium can easily replace copper in that solution. Okay? We will see the magnesium slowly disappear. The copper metal is forming on that magnesium metal. So what about silver? Silver is below copper. So if silver is below copper on this activity series, there should not be a reaction that is taking place between silver and copper chloride. Here's what that looks like. If I have silver metal and I add it to that same copper 2 chloride solution, there's no reaction at all. Because silver is below copper on that activity series, it's not going to replace the copper in the solution. Okay, last year we also talked about some solubility rules. Here is those rules laid out for you. Most ionic compounds dissolve in water because water has a slight charge, and ionic compounds have a charge. So remember, likes dissolve likes. If something has a charge, it's more likely to dissolve in something else that has a charge. Water can pull them apart into a solution. A small percentage of ionic compounds do not dissolve in water, though. The attraction between the positive and the negative ions is too strong. The solubility rules on the right tell us which ionic compounds dissolve and which don't, so you will have access to these solubility rules, and I believe they are listed on one of the Spark Notes handouts that's attached in your slides. Okay, so how do we write a net ionic equation? So we're going back to our equations. Writing a net ionic equation. So what we have been seeing is this molecular equation, okay? So this is the entire equation. We're on step 3 on those notes, and you have a box. This is the equation that you would write in the box. So the molecular equation tells us everything that's in it, everything that's in the reaction, the states that they're in, it's balanced, all of that stuff. Chemists prefer to write the net ionic equation for reactions that happen in water. All single and double displacement reactions happen in water. Replacement, sorry. In a net ionic reaction, we write the solids together, but we write compounds that dissolve in water apart as ions. So let's look at what that means. No physical states are listed because the way in which we write the substances indicates their physical state. So let's write this as an ionic reaction first. Okay, so in this ionic reaction, it's basically separating my compounds, but it's listing the charges. So instead of CuCl2, I would have Cu plus 2 and then 2Cl minus 1. Same thing on the right side. Mg would have a positive 2 charge, so I'd write that on there. And then my 2-chlorine would have a negative 1 charge. So this is how I would write it. So let's talk about writing the net ionic reaction. Here's my ionic reaction. This one is written without a charge because it starts as an elemental metal. It's coming straight from the periodic table. This one is written with a charge because it started out in a solution, right? It wasn't a single element by itself. It was a compound that was in a solution. It reacted with the chloride ion. This element is also written with a charge because it started in that solution, and we know it's going to react with that magnesium ion in a minute. This magnesium, because it was in that compound, magnesium chloride, it is also written with a charge. This one's written with a charge too, same reason. And then lastly, this one doesn't have a charge because that's just a straight element from the periodic table. So generally, if it's an element that's not bonded to anything, we don't need to write the charge. Okay, so again, here's my ionic reaction. So let's make it into a net ionic reaction. This is also important to note why we write that 2 as a big 2 as a coefficient instead of Cl2 little 2. When CuCl2 dissolves in water, the chlorine atoms are not attached to each other like in diatomic chloride, okay? So this is what it's written out in our molecular formula, which is what we started with, CuCl. So each chlorine is attached to my copper. And then this is how we actually are writing it out. So I have 2 chlorine. They're not bonded to each other. They're bonded to the copper. So if I wrote Cl2 with a little 2, that would make me think that chlorines were bonded to each other. But because I'm writing the big 2 in front of the chlorine, that tells me that I have 2 separate chlorine molecules. Okay, so continuing on this, scientists cross off any ions, atoms, or molecules in the ionic reaction that do not change during the course of the reaction. Those are called spectator ions. That basically is like crossing out the things that are the same on each side to simplify the reaction. Okay? The only thing that's appearing identical on both sides of this equation is that 2Cl with a negative 1 charge. Because that appears on each side of the triangle, I can just go ahead and cross those out. Okay? So doing that gives me the net ionic equation. Here's where I started out. My molecular equation tells me everything I need to know. The ionic lists the charges and breaks up those compounds. The net ionic simplifies it and gets rid of the spectator ions, the ones that are the same on both sides. Okay, so there's a few guided practice problems. The main thing you need to do on that is make sure you're writing down what type of reaction it is. So synthesis, decomposition, single replacement, double replacement, or combustion. And then you're writing out the whole equation. If it's something, excuse me, if it's something that can be simplified into that net ionic equation, then go ahead and practice doing that. If you guys need help, please email me or come to